Welcome to this lecture. We're going to be looking at right-angled triangles. So right-angled triangles are triangles which are noted with this square, which signifies that it is a 90-degree angled triangle. So for us in this lecture, we're going to look at the sides of the right-angled triangle. So for the sides of the right-angled triangle, you firstly take note of the angle which you're given. So this angle is our focal angle, the angle which is going to determine the sides. So for us to determine the side, whatever is opposite to the angle, we call this one the opposite. And then that which is opposite the right angle or the 90-degree, it is called the hypotenuse. So let's look at the example on the far corner. So for this example, we have an angle. Let's say this angle is theta. And then for theta, what is opposite theta? Here is the opposite. And then what is opposite this 90-degree? We term it to be the hypotenuse, which is longest side. And then the remaining one is the adjacent. Finding now the sides of the right-angled triangles can also help us to determine the trigonometric ratios. So the trigonometric ratios, we make use of the formula SOH CAH TOA. So for SOH CAH TOA, we find SOH representing sine x, which is equal to the opposite over the hypotenuse. So opposite over hypotenuse. Then CAH, we have it represented by cos x is equal to the adjacent over the hypotenuse. And then tan x, which is TOA, tan x is equal to opposite over adjacent. These trigonometric ratios help us in calculating the sides as well as calculating the angles. So for this first example, we're going to be finding the unknown side. So let us look at this example. So the example reads, find the length of the side labeled BC. So we want to firstly look at BC, which is B here, and we find our C here. So the side that we're going to be focusing on is this side, which is BC. So for us to find this side becomes our unknown, so we just place BC here. So for us now to see which formula we can use, we then go to our angle. Then what is opposite the angle will be the opposite. And then what is opposite the right angle is the hypotenuse. So now if we find the sides which are provided, we can be able to also calculate the unknown side. So here we have the opposite and the hypotenuse. So if we have the opposite and the hypotenuse, we go to where we have SOH. So this is the formula that we're going to be using. So for SOH, it will be sine theta is equal to opposite over hypotenuse. So let's look at it. So it's now sine, the angle here is 40 is equal to our opposite here is BC all over our hypotenuse here is 8. So we have sine 40 is equal to BC over 8. Then we multiply by 8 on both sides here to be left with BC. So our BC is now equal to 8 sine 40. So if it is 8 sine 40, using your calculator, we get BC being equal to 5.1. So this is the length of your side. Now going to example number 2, we have a scenario where we are asked to find the length of the side AB. So we go to our side. Here is A, here is B. So if you can see, this is the side which we are asked to calculate. So if we are asked to calculate this side can only be calculated using this triangle. You can only calculate it using this triangle. But in this triangle, that side is the opposite, but then we are not given any other quantity to use to calculate, so it means that we have to look at the other triangle to see if the other triangle can give us a particular quantity. So we have, let's look at this triangle that I'm placing with x's. So separating this triangle with x's, it is like this here, where we have our b and we have our d and we have our c and we have 10 here and we have 32, and we also have this side which is unknown, and this side is BD. We just name BD. So firstly we are going to find BD. Then after finding BD, that answer that we have found BD is the one that we are going to be using to find our side AB. So let's look at it. So for the calculations of BD, here are the calculations. For BD, we can check that it is opposite an angle, so it is opposite. Then the other value is the adjacent. So we have A and O. If we have A and O, it's TOA. We'll use this formula for TOA. Then that will be tan theta is equal to opposite over adjacent. So here we have our tan, and then our angle is 32 is equal to our opposite is BD all over our adjacent, that's 10. So which is equal to, then we multiply 10 on both sides. Multiplying 10 on both sides gives us 10 tan 32 is equal to BD. Then our BD, if we simplify it, our BD will be equal to 6.25. So we have firstly found this side BD. So this side BD is the one which we are going to be using to calculate the side for AB. So let us look at the triangle for the calculation of AB. Let's take the triangle as it is here. Then we have a corner. Then here we have 38 degrees. We have D, we have B, we have A. And then this side we have calculated that BD is equal to 6.25. And then here, this is the side that we want to calculate. So the side that we want to calculate, that's AB. So now using this, we are identifying the formula. The side which is opposite the angle is equal to the opposite, and the side opposite to the 90 degree is equal to the hypotenuse. So we have O and H, so which means we can make use of the formula. So then we have sine theta is equal to opposite over hypotenuse. Then we have our sine, the angle is 38, is equal to our opposite is AB, which is the value that we want, over the 6.25, which is our hypotenuse. So we multiply 6.25 on both sides. Then we get 6.25 sine 38 is equal to AB. So if we evaluate that 6.25 sine 38, we get 3.85 is equal to AB. So this will be our answer, our solution for finding the side AB. So remember, the first thing is you take note of what you want to find. It's AB. Then for you to find AB, you locate a triangle which helps you to find AB. Then after that, you see if there are any missing values. If there are missing values like this, you try to find how you can calculate the missing value using the other extension for the other triangle. Let's look at the third example. So for the third example, we are asked to calculate CD. it says find the length of CD. So for us to find the length of CD, we go to CD. Here is C, here is D. So before we find the length of C to D, we want to know what CD really is. Okay, now if you can find this length and you can find this length, let's say, so if this length and this length, you find the two of them. If you subtract the bigger length from the smaller length, that's how you find CD. So we calculate, we write our formula, which is for us to find CD, it will be equal to BD minus BC, which is equal to. So we now have a task to find BD and BC. So let's look at our calculation for finding BD. So for finding BD is here. We have B and we have D. So which means it's a bigger triangle. It's a bigger triangle. So we just try to represent the bigger triangle here, where we have our B and we have our D, and we have our angle here, and our angle here is coming from the bottom going to the top, so our angle is 50. So we have 50 here, and then we have 25 being down there. So we want to find BD, which means this is the side that we want to find. Okay, so let us locate. Here we find BD being the opposite and 25 being the adjacent. So if we have the adjacent and the opposite, we have OR and A. So we make use of TOA, which is the formula. Then we find tan theta is equal to opposite of adjacent, which is equal to, so we have tan of the angle is 50, and here the opposite is BD, all over the adjacent is 25. So for our BD, we find we multiply by 25 on both sides to cancel out. Then we have 25 tan 50. Since we are going to be using it under this, we are just going to leave it like this and then simplify later. So let's look at the other calculation. The other calculation is for BC. So for the calculation for BC, let us have our triangle. So for B to C, it is a smaller triangle. In that smaller triangle, we have BC, and we have our C, we have our B, and we have our A. So for B to A, it's 25. And then for our angle is starting from here up to here. So the full angle is 50, but from here to here we subtract the 10, and then here we get 40. So we bring 40 here. So under this, we want to calculate BC. So BC, we write our BC here. Then formulating 40, the angle is opposite to BC, so this is opposite and this is adjacent. We make use of TOA. Then we have tan theta is equal to opposite over adjacent, which is equal to, then tan of 40 will be equal to, our opposite is BC, all over the adjacent is 25. Then we multiply by 25 on both sides. Then we get 25 tan 40 being equal to BC. So we have firstly our BD and secondly our BC. So here CD is equal to BD minus BC. here. So our BD is 25 tan 50 minus our BC is 25 tan 40. So if we subtract 25 tan 50 minus 25 tan 40, we find ourselves having 8.82. So this will be the solution for our second example. Earlier on, we were looking at the calculation of a side. Now we want to also consider an unknown angle. So for us to have an unknown angle, we have to firstly consider how we can find the angle when you are given a particular data. For example, in this case, we have sine theta being equal to 2/3. So for us to find theta, it will be equal to the arcsine of 2/3. The arcsine of 2/3, when you use our calculator, it gives us 41.8 degrees. Then we look at the second one. Cos theta is equal to 2/3. So for us to find theta, it will be equivalent to arc cos of 2/3. The arc cos of 2/3 gives us a value of 48.2 degrees. Then we look at the third example. It's for tan. So the theta will be equal to the arctan of 2/3. Then if we evaluate using a calculator, it gives us 33.7 degrees. So these are our values when we want to find the angle when you're given the other values. So for example, here for sine theta, sine theta is opposite over hypotenuse. So this is the opposite, this is the hypotenuse. For cos theta is equal to adjacent over hypotenuse. So this will be our adjacent, this will be our hypotenuse. Then for tan theta, it is equal to opposite over adjacent. So this will be our opposite, this will be our adjacent. So these ones may be used for future references. Now, having heard how we calculate the angle, it is very important for us to also do an example to make sure that we can calculate the angles. So the question reads, for example, number 1, it reads, calculate the angle marked theta. So we want to calculate this angle which is marked theta. So theta, if you look closely, look, the one which is opposite theta is what we call the opposite, and then this one 8 is opposite the right angle, it is the hypotenuse. So we have H and O, so which means we will be having the formula so it will be sine theta will be equal to opposite over hypotenuse, which is equal to, then we have sine of theta, which is our angle, will be equal to opposite, which is 6, over the hypotenuse, which is 8. Then if we have this now, for us to find our theta here will be equal to the arcsine of 6/8. And then the arcsine of 6/8 will give us a value of 48.6 degrees. This will be our value. Now let us consider the last example, which is example number 2. So for example number 2, we are asked to calculate the angle which is marked theta. The angle marked theta here is this one. But for us to find theta, let us look, it is an angle which is at C. Let us try to look at the right angle which we are going to be focusing on for us to find that, since we are doing trigonometric ratios. So this will be the triangle that will have to give you the value for theta. So if you want to find theta, then this would have to be the opposite and this would have to be the hypotenuse. But here we don't have we have an unknown angle and also an unknown opposite. So which means that we need to find the opposite. So we will find the opposite using this triangle that I've marked. So the opposite, our opposite is BD. So let us firstly calculate for BD. For BD we have this triangle. If here we have our B, we have our D, and we have our A. And then here we have 4, here we have 40, and here we have nothing. So we want to find BD. Our BD is this one. So our BD is opposite the angle, it is the opposite. And then our 4, it is the adjacent. So we have OA. So which means that we make use of the formula TOA. Then we have tan theta is equals to opposite over adjacent, which is equal to, then we have tan of 40 degrees being equal to, our opposite here is BD all over 4. If we multiply on both sides by 4, we find 4 tan 40 being equivalent to BD. So that 4 tan 40, we can simplify it as simply 3.6 being equal to BD. This is a simplified one. Then after calculating the BD, which means we have this value, which is 3.6, we now need to know how we can find the angle. So we are going to be making calculations for theta. So this will be the triangle in use. We have our B, we have our D, and we have our C. So for our BD, we have 3.6, and then for this side, which is DC, we have 5. So, and then here we have theta, which is our angle. So if we do this, here we have opposite, here we have the hypotenuse, we have O and H, which means we are going to make use of SOH. So we have sine theta is equal to opposite over hypotenuse, which is equal to, then we have sine of the angle is theta is equal to, our opposite is 3.6 all over our hypotenuse, which is 5. So for us to find theta, it will be equal to the arcsine of 3.6 all over 5. Evaluating the arcsine for 3 over 6 over 5, it gives us 40.6 degrees. So this is how you deal with right angle triangles pertaining to the trigonometric ratios. So remember, when you are dealing with trigonometric ratios, you're just dealing with the issue SOH CAH TOA. These are the only rules that you're going to be using, especially when you want to find the angle and the side of the trigonometrical ratios as well as trigonometrical values. Thank you.